Hi everyone, so this is our video about the project of eco-friendly bicycle lighting system using dynamo generator. So let us introduce ourselves. My name is Abdul Rashid bin Qasim, DE240109.
And my name is Soimi bin Majiri, CE24003. Okay, right now, let's see what component we use for our project. Okay, one of the component we use is a headlight. The second one is a tail light. And the last one is a dynamo itself, dynamo generator. Before we do a demonstration, let's our friend talk about the theory behind our project.
Hi, my name is Muhammad Irfan bin Razali and my case number is CE240230. So I will explain about the theory. So basically, the working principle of a dynamo generator is based on Faraday's law of the electromagnetic induction. So when the wheel of rotor rotates, it provides mechanical energy that causes the permanent magnet to move relative to the traction coil. So this movement changes the magnetic flux passing through the coil over time. Other than that, according to the Faraday's law, a changing magnetic flux induces an electromotive force, which is EMF, in the coil. The faster the rotation, the greater the rates of change of magnetic flux. As a result, in higher induced voltage. Since the magnetic field continue change direction as the magnet rotates, the induced voltage also alternates between positive and negative values, producing an AC output. Therefore, the dynamo generator converts mechanical energy into the electrical energy to the electromagnetic induction.
Hi, my name is Muhammad Fakram bin Muhammad Asri. My matrix number is DE24006 and I am going to be explaining about the operational flowchart of our project in time-varying fields to generate AC voltage using a dynamo on a bicycle. So, first we have to understand the structure of the dynamo, which is it have a simple, actually, it only have a coil and also permanent magnet. The coil can be moved inside the dynamo. So what we do is, for first, when we rotate the bicycle wheel, the dynamo will engage with the wheel, which will rotate the coil inside the dynamo, and the coil will rotate near the magnet. So Faraday's law said that every time a magnet moves near a coil, a voltage will be induced into the coil. So from that, AC voltage will be generated. So the generated AC voltage we use to power the bicycle headlamp and also the tail light.
Okay, now I want to demonstrate and explain a little bit about how the generator, that is dynamo, working. So in summary, when we cycle the pedal, the tire will be moving, and then the dynamo that attached with the tire will be moving together with the tire, and then the power will supply into the wire, and then the bulb front and back tail lamp will light up. So let's go to the demonstration, how it works. Come here.
Okay, that's all for our demonstration. We're moving to the next part.
Hello, my name is Nurin Nasuha Al-Husaini binti Ahmad Fakrul Razi with DE 2.0111. Okay, so now let's look at the empirical data we gathered to evaluate how the bicycle speed directly impacts our electrical output. We tested the prototype across 3 distinct speed intervals. First, at a low speed of under 5 km per hour, the rate of magnetic flux change is minimal. This yields a low voltage of just 1.2 to 1.8 volts, which results in a dim illumination with some minor flickering. Next, when moving at a normal cruising speed of 10 to 15 km per hour, the flux change becomes moderate and steady. The measured voltage rises significantly to between 3.5 to and 4.8 volts, providing a bright, highly stable and continuous light beam. Finally, at a high speed of over 20 km per hour, we achieve maximum and rapid flux change. This generates a peak voltage of 5.5 to 6 volts. At this level, the LEDs has reached maximum brightness, and our integrated conditioning circuit and capacitor successfully step in to smooth out any erratic voltage spikes, protecting the components from overloading. This data perfectly validates Faraday's law, which higher speeds cause a more rapid change in a magnetic flux, which directly yields a higher induced EMF. Ultimately, the circuit successfully stabilizes this erratic raw AC energy into a highly reliable zero-carbon power source. Okay, so in conclusion, this project successfully demonstrates how fundamental physics concepts can be translated into a practical real-world application by capturing raw kinetic energy and converting it into stable electricity. We have built a fully functional prototype. The final product provides a safe, completely battery-free and zero-waste lighting alternative for cyclists. It proves that we can enhance rider safety during night commutes without relying on chemical batteries that eventually will harm our environment. That's all from our group. Thank you so much.